Alright, so we're going to look at the critical path method. And okay, so based on the previous table, it indicates that it would take 25 weeks to complete this task. That is pretend that says weeks. That is a typo. So 25 weeks to complete this task. Well, how long do we have to do this? We had 16 weeks. So according to PERT, we're over our limit. But CPM shows us that might not be the case, and it actually isn't the case, and we'll show that. So different activities can be happening at the same time because we had two different routes. Those are two things that could be happening concurrently. And critical path method opens up the possibility of finding slack or determining truly how long a project should take. So the critical path is the longest time path route through the network. That's going to be important on the quiz. If we want to reduce the total project time, we will reduce the length of some activity on the critical path. The critical path is the longest time path route through the network. So if you lower the critical path, you should, in theory, lower the time it takes for that project to be completed. And once the critical path, if you lower the time that it takes to accomplish one of those tasks on the critical path, your critical path could change. It could be fluid, and in many cases it will be fluid. So conversely, any delay on the critical path will delay the completion of the entire project. Critical path, you have earliest and latest start times. Each activity has an earliest possible start time and an earliest possible finish time. They also have a latest start time and a latest finish time. And there's some formulas to determine that, but essentially we're going to do a forward pass through our route, and we're going to determine the earliest finish and earliest start times, and then we're going to do a backwards pass to determine the late start and late finish times. So using the values from a few slides ago, we know that there's no precedent activity before A or B, so we're going to start at 0. And step A, and let me get the exact slide reference here that you can reference these times. That is on slide number 12. The expected time to accomplish step A is 2 weeks, and B is 3 weeks. So you have 0 and 2, 0 and 3. Now C is going to be fed by A, so their earliest start time is 2 weeks, because you can't start any earlier than that. And D, their earliest start time is 3 weeks, because it can't start any earlier than 3. This continues on, and where it gets interesting is G. G's earliest start time is 8. Why is it 8? Because even if D gets done at 7 weeks, it's still going to wait for the latest earliest start time from its precedence. So it's going to start at 8 because E finishes at 8. So we're going to do a forward pass and mark all of the early start and early finish times. Early finish time is just the early start time plus the expected amount of weeks it takes to accomplish it. And next we're going to go through the late start and late finish path.